Okay. Thank you so much for this opportunity from the Montfort University. Going to present in my journal, which I have submitted for the review. It is really for the gas sensor array data set, which is available publicly, and I did the classification by using the deep learning algorithms. My name is Muhammad Jaleel, and my supervisors are Dr. Hussein and Dr. Abbas from the Computing Engineering Department. So first of all, before to move on, we must know about and the sense of sensors. We categorize the sensors into two important features, which are the precision and accuracy. Because if a sensor doesn't have good precision and accuracy, then it cannot be performed very well. So precision, basically, these are the values which are very close to each other when you did two or the data sets, and these results must be very similar to each others. And in the form accuracy, there are two values. The first one is the standard values, and the second one is the measured values. And these values must be very close to each other to enhance or to check the accuracy of any sensors. If there is a huge difference between both of them, then this means that the accuracy is not so good, and we have to do a lot of work to close these values each other. And in the sensor precision, if the precision of the sensors must be very high, and in the form of drifting, the drift directly affect the sensor accuracy, and which cause two of the targets of these sensors. And what is the sensor drift? Basically, this is a natural phenomena which affects all these sensors, because there is a lot of sensors we are using in the fields. Suppose that if I am talking about, if I talk about the gas sensors, then there is a huge pipeline where we install the sensors. So there are a lot of sensors in a line which can affect by the drift. And also it changes the physical change. It can cause a physical changes in the sensors. It affects the sensors accuracy. What are the causes? It can during the sensor installation, there are a lot of causes which create the drift in the sensors. Like that, if you are installing a sensor, then you can press the sensors hardly, then it can affect, because these are very sensitive. The second is, and the very most important, is the contamination in the airs, because most of the sensor we deploy in open environments where where we cannot go many times. So we install the sensors to collect the values hybridly or remotely. So we install it there, and it causes it causes the dust and the chemicals and vapors layers on the sensors, which cause the drift in the sensors. And what are the effects? The process will be slowed for the monitoring system. Suppose that if we are collecting the data remotely through wireless or RFID, so the process can be slow. And if the process can be slow, this means that you cannot get any reliable data for your experiments or for any of the decisions. So in this, so let's come to the point. What is basically the problem in this work? The problem is the multi-class classification, the feature extractions, and to perform a best classification algorithm to enhance the classification accuracy. They basically, as I discussed before, that this data set is available publicly, and it is a multi-class data set. There are different gases has been targeted to classify them. And the second is the feature extraction. A lot of work has been done before, which have done the feature extraction by hands, not with the automated features to enhance the classification accuracy. And this is an overview of the related work, which shows that a lot of work has done before, where different researchers have done this different work with the different algorithms, machine learning algorithm. Let's start with the first gas sensor data set. This basically this data set is collected by a 4x4 sensor array. This means that the 16 sensors are used to collect this data set, and it is collected in a laboratory. And then this data set pass through the data pre-processing, where it is normalized and labeling. In the normalization, they use two types of methods. One is one -1 to 1 values to normalize the data, or directly they use the normalization in the Python to normalize, which is basically a direct method to normalize the data without any large codings. And the next is the feature actually gets the most important features, and two analyses are mostly are used in literature. The first one is the principal component analysis and the linear discriminant analysis. But in these both methods, the mostly used method is the principal component analysis, which is robust and very quick. And then is the gas classification on the concerned data sets. They use the machine learning and neural network, which I am going to define. I'm going to present in my next slides, and then to perform the classification accuracy. So this is basically data sets on the UCI repository, and this data set is collected in 2014 in a laboratory, and where 6 different gases are targeted, and with the different concentration levels, and this is these months are categorized into batches. Months 1 and 2 are in a batch, or 1, 3, 4, 8, 9, and 10 in batch 2, and so on. So, so in this work, we are going to play with the batches. That different months are stored in the batch folder, and then we can use these folders for the classification purpose. So this is the proposed technique where a data set is collected by the 4x4 sensor array. Then we pass through it from the data pre-processing, where the feature extraction and feature selections done itself, and then then it moves to the algorithm there, where different machine learning algorithm and the convolutional neural networks are defined to classify the data. And in model preparation, there is a different technique has been used. That one is the training data set and the testing data sets. As I told you before, that this is basically the batches data set. So different batches are used for the training and the testing data sets, and then we perform the classification results. Here I use two technique, and the second is a deep convolution neural network to perform the experiment and for the comparison. So this is the cluster here, where there are some batches: the batch 1, batch 2, to batch 10 we have, and the first batch, the initial batch, is used for the training data set, and the in generalized, then the first batch will use for the training, next batch will use for the testing process, and then we perform the classification process.
Mohammed, you have 2 minutes left, and then we take questions.
Rather we are using the machine learning, or rather we are using the deep learning technologies.
Mohammed, 2 minutes, and then we take questions.
Okay. So the machine learning algorithm, there are we are using different k nearest neighbor, the C and tree, random forest, support vector, and gradient boosting trees. With the parameters, we use a grid search classify, which use the automated features to select the parameters for the best classification purpose. And this is the deep convolutional neural network where total number of layers are 36. That are 32 convolution layer, one batch normalization, and one rel activations. And then lastly, I use the global average pooling and the one fully connected layer with atom optimization. This is called as a gas-mass convolutional neural network. We use this network for our data sets to enhance the classification performance. So this is the comparison analysis. We can see that most of the results are very similar to each other, and in comparison, that the GasNet CNN accuracy and the minimum accuracy, which is at 6478. But in this case, we the computation time. The computation time in the GasNet is 0.042 seconds, rather than if we discuss about the random forest, the time is 35.38 seconds. So our system is very good in the computation time, because this is a large data set. So computation time is very important. So the GasNet CNN it performed very good and very outperformed rather than the others with the less computation time. So this is the conclusion. We use the different machine learning algorithms and neural and compare it with the deep learning and enhance the performance of the classification. Propose a GasNet deep neural network for the gas classification, and it performs better than the others with the less computation time. So thank you so much for the time. And if you have any questions, then you must let me know, please.
Okay, thank you very much for that engaging presentation. We'll take questions if there's any question in the room. And our online participants, do you have any question?
Yes, can I ask a question?
Yes, you can.
Okay, thank you for your presentation. It was interesting project, especially you used the neural network for real world applications. My question is related to the sensors you have been used. You say that you collect the data at the lab. Could you please give a more detail about the procedure that you use to take this kind of data? I am interested to the amino because we have some project that we interested to identify the ammonia.
Thank you for the question. At the start of my presentation, I explained that this data set is available publicly. I didn't collect the data sets, but this data set is collected by the MOX sensors, multi-oxide gas sensors, and it is collected in the control laboratory. And the data set is available on UCI repository, machine learning, where you can find this data set. If you need any more information, then must let me know. I am also collecting the data sets virtually through the Arduino and presenting the values and the data on the lab view. And it is it is in the final stage. And if you need any more information, then just let me know, and I am here to help you. But this data set is available online.
Okay, about this simulation tools, you simulate this data, or you directly use that sensor in your Arduino? Or you direct sensor in your Arduino?
Basically, this data set is totally different from my ongoing work. That I am using the simulation on the Proteus and this Proteus is connected with the LabVIEW to a virtual serial drive port. So, which I am doing on the Proteus, and we are collecting the data on the LabVIEW through the MOX sensors. But in this presentation, I use a publicly available data sets, and in this data sets, they are also use the MOX sensors.
Okay, thank you.